objective of this experiment is to verify the Ohm's law principle. The materials used in this experiment is the PhET simulator, circuit construction kit DC.
If the electron current is shown, the electron flow is shown from negative to positive. However, if the conventional current is shown, the current flow is shown from positive to negative. In first trial, the resistance is 24 ohm, the experimental voltage is 9.0 volts, and the experimental current is 0.37 ampere. In second trial, the resistance is 48 ohm, the experimental voltage is 9.0 volts, and the experimental current is 0.19 ampere. In third trial, the resistance is 72 ohm, the experimental voltage is 9.0 volts, and the experimental current is 0.12 ampere. In fourth trial, the resistance is 96 ohm, the experimental voltage is 9.0 volts, and the experimental current is 0.09 ampere. In fifth trial, the resistance is 120 ohm, the experimental voltage is 9.0 volts, and the experimental current is 0.07 ampere. First, enter the circuit construction kit DC and click Lab. Second, click and drag battery, then rotate the battery by turning the top part. Third, click and drag the resistor to the opposite side of the battery and turn it around until the bottom part is a tolerance band. Fourth, click and drag the switch and place it under the battery. Fifth, click and drag the ammeter and place it on top between the battery and resistor to determine the experimental current. Sixth, connect the ammeter, battery, switch, and resistor using wire. Seventh, click and drag the voltmeter and connect the tube probe in resistor to determine the experimental voltage. 8. Click the resistor and set the resistance in an increasing manner, then click the current electrons and conventional, then observe what will happen. Multiply the resistance and experimental current to get the theoretical voltage, then divide the experimental voltage and resistance to get the theoretical current. First trial, resistance is 24 ohm, experimental voltage is 9.0 volts, experimental current is 0.37 ampere, theoretical voltage is 8.88 volts, and the theoretical current is 0.375 ampere. Second trial, resistance is 48 ohm, experimental voltage is 9.0 volts, experimental current is 0.19 ampere, theoretical voltage is 9.12 volts, and the theoretical current is 0.1875 ampere. Third trial, resistance is 72 ohm, experimental voltage is 9.0 volts, experimental current is 0.12 ampere, theoretical voltage is 8.64 volts, and the theoretical current is 0.125 ampere. Fourth trial, resistance is 96 ohm, experimental voltage is 9.0 volts, experimental current is 0.09 ampere, theoretical voltage is 8.64 volts, and the theoretical current is 0.09375 ampere. Fifth trial, resistance is 120 ohm, experimental voltage is 9.0 volts, experimental current is 0.07 ampere, theoretical voltage is 8.0 volts, and the theoretical current is 0.075 ampere. Here are our solvings.
The experiment used FET simulator circuit construction to aid our learning on the concept of Ohm's law. Ohm's law states that if resistance is the ratio of potential difference or voltage applied across the ends of conductor to the current in the conductor. Its mathematical relationship is expressed as R is equals to V over I, wherein R is resistance with a unit of ohm named after George Ohm, and V is the potential difference or voltage with a unit of volts, and I is the current with a unit of ampere. It is important to note that this law is only valid for a certain ohmic material such as copper and aluminum. To expound, in Ohm's law, current is the flow of charge, while voltage is the measure of the difference in electric potential between 2 points. When a voltage source is connected to a conductor, it applies a potential difference that creates an electric field. The electric field in turn exerts force on charges, causing an electric current. Furthermore, the electric property that limits or hinders the current is called resistance.
So the experiment allowed us to clearly visualize the experimental application of the Ohm's law. To expound, the experiment will be categorized into two ways. It is important to note that through the experiment, the controlled variable is the resistance, which increased continuously in the 5 trials that we have made. First way was conducted through the FET simulator, specifically the Circuit Construction Kit DC simulation that uses the ammeter-voltmeter method, in where the ammeter is used to measure the current that passes a single point in the circuit. Meanwhile, the voltmeter is used to measure the electric potential difference between 2 points in the electric circuit. In short, ammeter is for the current and the voltmeter is for the potential difference, or to what we know as voltage. Moreover, the FET simulator was used to determine the experimental voltage and experimental current. It is consist of 5 trials wherein all experimental voltage was equal to 9 volts since it came from a 9 volts battery. In trial 1, the resistance is 24 ohms and it has the experimental current of 0.37 amperes. In trial 2, the resistance is 48 ohms while the experimental current is equal to 0.19 amperes. In the third trial, the resistance is 72 ohms and the experimental current is 0.12 amperes. In fourth trial, the resistance is 96 ohms and the experimental current is 0.09 amperes. And finally, in trial 5, resistance is 120 ohms and it has an experimental current of 0.07 amperes.
The second way is through solving with the use of the formula resistance is equal to voltage over current from the Ohm's law. It also consists of 5 trials with the same amount of resistance with the first way. In trial 1, theoretical voltage is 8.88 volts and the theoretical current is 0.375 ampere. In trial 2, theoretical voltage is 9.12 volts and theoretical current is 0.1875 ampere. In trial number 3, theoretical voltage is 8.64 volts and theoretical current is 0.125 ampere. In trial number 4, theoretical voltage is 8.64 volts and theoretical current is 0.09375 ampere. Finally, in trial number 5, theoretical voltage is 8.4 volts and theoretical current is 0.075 ampere. There are 3 additional observations from the FET simulator. First, as we adjust the value of the resistance in increasing order, the resistor's color bands changes as well. Second, when the electron current is selected, blue circles appear on the electric circuit and it flows from the negative to the positive side. Meanwhile, Third, when the conventional current is selected, red arrows appear on the electric circuit and it flows from the positive to the negative side. Furthermore, as the resistance of the 5 trial increases, there is a decrease in the speed of the flow of the blue circles in the electron current and the red arrows in the conventional current.
After the experiment was conducted, we have made multiple analyses on the two ways conducted. First, in the experimental values of voltage and current, we have analyzed that as the resistance of the resistor increased in the 5 trials, the experimental voltage remained constant, while the experimental current continuously decreased. As for the theoretical values of voltage and current, as the resistance of the resistor increased in the 5 trials, the theoretical voltage remained close to the value of the experimental voltage, which is 9 volts, while the theoretical current continuously decreased as well and remained close to the corresponding value of the experimental current per trial. This can be seen in trials 1 and 5, wherein trial 1 showed the least resistance of 24 ohms and the highest current of 0.378, while trial 5 showed the greatest resistance of 120 ohms and the lowest current of 0.078. Moreover, it is important to keep in mind that the values of the experimental and theoretical voltage and current are significantly close from each other with less than 1 difference. This signifies that the experimental and theoretical values of voltage and current are accurately measured and solved. Furthermore, this also proves the concept of Ohm's law, wherein, with the presence of a resistor in a circuit, the speed of the flow of the current decreases because, as stated in the Ohm's law, resistance is inversely proportional to current, and to increase the speed of the flow of the current, a larger amount of voltage is required.
The Ohm's law describes resistance as the opposition or hindrance to the current flow, wherein it is, first, directly proportional to the potential difference or voltage of the circuit, which means as the value of the resistance increase, the potential difference must increase as well. Second, it is inversely proportional to the current, which means as the value of the resistance increase, the flow of the current slows down or decreases. In short, higher resistance requires higher voltage for the current to flow, and vice versa. Finally, a resistor is used to implement resistance in a circuit. An ammeter is used to measure the current in a circuit, and a voltmeter is used to measure the electric potential difference in a circuit.